Welcome back, Math Marvels. This is lesson 68. We're going to find the probability of compound events. That means more than one event. So as I'm modeling, look out for these things. Watch how I create an organized visual representation using a tree diagram or a matrix. Watch how we represent probability of the two events with fractions. And so I can even do 3 or 4 events using fractions. So take a look and consider how I can do that. When you know 2, you can figure out 3 and 4. And finally, calculate probability using the product of the two events represented as a fraction. Once you watch me do it, think about how to apply it in your work as well so you can get to mastery by the exit ticket. When we have one event, we can make a list of outcomes. But when we have 2 events, we have even more possible outcomes. So let's take a look at how I use a visual to show all the possible things that can happen with 2 events. Jose and Ricky are playing rock, paper, scissors. What is the probability at least one person will pick rock? So that's what we're going to look for. The probability of at least one person picking rock. We're going to draw a tree diagram of the outcomes. Okay, so they're playing the game. And what could be the first thing that happens in the game? So we have one person might pick rock, paper, or scissors. So these are the 3 things that can happen when one person is playing, if it was just one. But because there are 2 people, let's say this is just Jose playing. He can either go rock, paper, or scissors. But there are 2 people. So now we're going to add the second event, which is Ricky. And let's say Jose puts out rock. Ricky might also put out rock, or paper, or scissors. So now you can see there are already 3 possible things that can happen. It can be a rock and a rock, where Jose has a rock and Rick has a rock. Jose has a rock and Rick throws paper. Jose throws rock and Rick throws scissors. Now, let's say it's paper. Jose throws paper. What could happen? He throws paper. Rick throws rock. He might throw paper. Rick might throw paper too. He might throw paper, Jose, and Rick might throw scissors. So now we can see that there are 6 possible things that can happen. What if he throws scissors? Again, if he throws scissors, Rick might throw a rock. Jose might do scissors. Rick might throw paper. Jose might do scissors. Rick might throw scissors. Okay, so my diagram kind of tells me what the first thing happens, which is Jose throws rock and then Rick throws something. So this counts as, for those 2 events, for Jose and Ricky, there are 1, 2, 3, 4, 5, 6, 7, 8, 9 things that can happen. There are 9 outcomes. And my outcomes are a combination of what Jose does and what Rick does. And that's what's so amazing about probability. It gets really complicated the more events you add into it. So it wasn't just Jose could do 3 things and Rick does 3 things. So there should be 6 things. No, it's much larger than that. Alright, so let's do the probability of anyone getting rock. Any rocks. So let's look and see. I'm going to look here first. It could be a rock and a rock papers, and a rock scissors. Here it could be paper then rock. I'm skipping paper because there's no rock. I'm skipping paper, scissors. There could be scissors rock. There could be scissors paper, and there could be scissors scissors. So out of those 9 things, there are at least 1, 2, 3, 4. There are 5 things that can have 5 outcomes that have rock. So I'm going to represent that as 5 out of 9. And as always, we're going to turn this into a decimal. 9 goes into 55 times. Goes into 55 times again, so you can tell this is going to be repeating. So we're going to round this to 5600ths or 56%. So major takeaway, all I'm doing here is I'm using my tree diagram to say what are all the things that happen with one event. This is my first event, and then in my next row I add the second event. And notice I'm using a combination so you can see both events on my list. Hit pause and jot this down into your notes. Let's look at our second problem. Carmen has 3 uniform shirts for school: a blue polo, a white polo, and a gym t-shirt. She also has 4 different bottoms she can use: a gym sweats, black slacks, her khakis, or a skirt. So just so you can see, she has 3 different shirts, 4 different bottoms. How many combinations can she make? What percent of outfits have gym clothes? Create a matrix or a chart to show your work. Okay. So I actually like a matrix way better than a tree. It's easier to draw and it's so much more organized. So I'm going to have the shirts on top and the bottoms on the side. And we know there are 4 bottoms and there are 3 shirts. So I'm going to make a big, let's do this in green, big rectangle. And for you at home in your notes, you can either use square grid paper, that can be really helpful, or graph paper for this. And I'm going to split this up so that I have the 4 bottoms. So I'm going to make 4 rows. And I'm going to have 3 columns. Now I'm going to name the columns and name the rows so we know the categories we have. For shirts, we have the blue polo, we have a white polo, and we have a gym t-shirt. And for the bottoms, we have her gym sweats, we have the slacks, black slacks, we have the khakis, or the skirt. Alright, now inside the box is just like when you used to do a raise when you were little. You're going to put a combination. This box over here, I just go up to find the type of shirt and over to find the sweats. If I wanted to know what was in this box, from here, I would know I'd have a white polo and khaki. So you're doing a lot of vertical and horizontal lines to figure out what's in the box. So giving yourself some, you can use abbreviations if it really helps. So in the first box, we have the blue polo and we have the gym sweats. I'll keep going down the line. Blue polo or the black slacks. And you can see how this can take a lot of time. So I just want you to see it, and I'm going to use abbreviations to kind of help. So BP for blue polo, skirt, white polo, I know this whole row is going to be white polo, white polo, and now I have gym sweats, black slacks, khakis, skirt. Last row, I have the gym tee, gym tee, gym tee, gym tee, and now again I'm just looking across to do the last set, and this is the gym sweats, black slacks, khaki, skirt. And I want to know how many combinations she can make there are 12 combinations. So think about what operation you notice, marbles. For 3 shirts and 4 bottoms, I get 12 combinations. So what operation can you think of that would make 12? You probably are saying multiplication, multiplication. And that's going to be key in the next lesson coming up. All right, in the second one, what percent have gym clothes? So percent with gym clothes. So out of 12, look and see where do you notice the gym clothes. So I'm going to go down this entire row for gym clothes. And I'm going to go across on this part for gym clothes. But notice I'm not going to count this one twice. It's still one combination. So how many combinations have gym clothes? 1, 2, 3, 4, 5, 6 combinations have gym clothes. So I'm going to turn that into well, let's simplify it, 1/2. Turn this into a decimal. That's easy. That's 50 hundredths or 50%. So here's my second answer. What percent of outfits have gym clothes? 50% of outfits. Have gym clothes. Hit pause and jot this down into your notes. And imagine what this would have looked like if we had done a tree diagram instead of a matrix. Let's do one more. Ronnie is playing Monopoly. So we get some choice here. We're going to use a tree or matrix to show all the possible combinations when rolling 2 dice. He wants to roll a double. What is the probability of rolling a double? So they're getting the same number on both. I find the tree diagram can get kind of messy and you can get confused writing things. So I'm going to do a matrix. And on my top part, I want you to think of the first dice. What are all the things that can happen with the first dice? I can have a 1, 2, a 3, a 4, a 5, or a 6. And the same thing can happen with my second dice. And I'll do the same thing going in this direction. And using line paper works really, really well for this. I already have the squares. So let's start filling this in. First off, you can already see how many combinations are here. We know we have 6 on top and 6 on the side. So rather than counting, I know I'm going to have 36 outcomes. Because I know that the number of outcomes will be the product of the first object and the second object. So that's why I'm getting 36. And you can see it. You can see I have 36 boxes here. You can hit pause and count it if you'd like. Now we're going to roll the dice and try to fill in so we can see all the combinations. Now that does take time. So what I could do is actually find the ones and just fill in the things that I want to happen. So in this case, I know I can get a 1 and a 1, so I'm going to put that in the box. 1 and 1, 2 and 2. When I get a 3 and a 3, because I'm only looking for doubles. So I'm only filling out the ones that give me doubles. And there you go. Those are the only times I will have doubles out of all 36. And if you're a little uneasy and you want to try it out, I'll just fill in the first row so you can see I could have a 1 and a 2, a 1 and a 3, a 1 and a 4, a 1 and a 5, a 1 and a 6. So the only one that I really want on that row is here, the 1 and the 1. So for time's sake, you can see how I can do some thinking. Where would I see the outcomes I want? And let me fill those in. Okay, so looking there, how many combinations are the ones that I wanted? 1, 2, 3, 4, 5, 6. The probability of rolling a double is 6 out of 36, or simplified 1 out of 6. I'm going to change that into a percentage, and I know 1/6 is equal to 0 and 1/666 repeated, or 0 and 17 hundredths, or 17%. And that's it, Math Marbles. Now you know how you can create a visual when you have two compound events. You can use either a tree diagram or you can use a matrix. I find a matrix much easier, but both of them take some time in the beginning, so give yourself a lot of room to write and a lot of space. Some kids wanted to see the entire matrix filled out, so I'm just back. So hit pause if you wanted to see your entire matrix filled out. I started with this number on the side as the first number, so you'll see they all match this number first, and this was second. All right, I will see you in the next lesson. Be well.